Hello. This lesson is a direct follow-up to complex triangle problems. So make sure you understand complex triangle problems before you do this. Same aim except for the end. I can find angles of a triangle by looking for linear pairs and angles of a triangle. Also using isosceles, angle bisector, and equilateral definitions. And now following the transversal when given parallel lines. So it's the same thing that we were doing, but now we're incorporating what we did in the last lesson into it, which is following the transversal and parallel lines. In the diagram below, FAD is parallel to EHC. So when I see parallel, I want to think of that picture. FAB equals 48 degrees. ECB is 18 degrees. Well, when I see parallel, I want to see this picture. So I'm going to extend my parallel lines. I don't really need to in this particular problem because they're already extended. And identify, extend, and follow the transversal. So the transversal that hits those two parallel lines is this one right here. So now I see my 1, 2, 3, 4, 5, 6, 7, 8 angles. If this angle's 48, then this angle's 48. I follow the transversal to H. H is where the transversal hits the other parallel line. So these acute angles must be 48 as well. I can fill in the obtuse angles if needed, but it doesn't look like I'm going to need to in this example. Now that I have that, again, it's the same thing we did in that complex triangles lesson. Look for linear pairs, angles of a triangle. I have two angles of a triangle. 48 plus 18 is 66. 180 minus 66 is 114. And now that I have that, I have a linear pair. 180 minus 114 is 66. What you could have also done to find this, exterior angle theorem, this must be equal to the sum of the two interior angles that aren't touching it. But, I'd rather you just do it the process which we just did it. Either way, this is 66 degrees. ABC is 66 degrees. This is not going to be a long video. There's really very little that's new. It's just incorporating parallel. When you see parallel, I want to see this picture. To get that picture, extend your parallel lines, extend and follow your transversal. The letters where the transversal hits your two parallel lines, that's where your congruent angles are going to go. So let's just do one more. And then after that, it's really up to you to just practice this. I think it's big enough. In the diagram below, ABC is parallel to EFG. So I'm going to extend my parallel lines. I'm going to hold off on the transversal for the moment to figure out what it is I need. It tells me that BF is congruent to EF. So when it tells me the two sides are congruent, I mark those sides and the angles opposite them. BF, EF. So this angle and this angle must be the same. It says that angle CBF equals 42.5. Well, since I have parallel lines, the transversal that contains that 42.5 is this one. I extend it and I follow it. At what letter does it hit the other parallel line? F. So if this is 42.5 and this is 42.5, when I follow my transversal, F also has 42.5. 42.5. Now that I did that, I've got angles of a triangle. I don't have two, but since those two are equal, I can do 180 minus 42.5. That's 137.5. I take 137.5, I divide it by 2. I get 68.75 degrees. So this is a short video, not that because this is necessarily easy, but because you need to spend the time and put it all together. But what's the only thing that's new is now when I see parallel, I need to extend the parallel lines, extend and follow the transversal, so whatever angles I have at B, I'm going to have the same ones at F. Other than that, it's the same thing as the complex triangle problems lesson. It's on you to practice, so practice. That's all I got.